Okay, so we know none of these trig functions is one-to-one, therefore none of them has inverse. But how do we create sine inverse, right? And what is the inverse to, right? Because when we talk about inverse function, we always have a pair of numbers, and we have addressed these, the relationship between, recall, right? Recall if one function has inverse, right? And so is one-to-one, right? If f of x is one-to-one, its inverse, f of inverse is the inverse of f of x. They have some relationship, right? There's some relationship. So what are those relationships? We have seen those relationships, right? So suppose we have f here, right? We have f inverse there. And in terms of domain, one's domain is the other's range. One's domain is other's range. So this is the domain, right? Take the example of e to the power x, right? I'm using an example. Its inverse is ln x. In terms of their domain, right? The domain x is greater than 0. But this is all real numbers. I'm sorry, it's all real numbers. Okay. And with the example, okay, this is the example. I just want to recall this. Okay, and the range over here, e to the power x is larger than 0, always. And what will be the domain for ln x? Well, this x must be greater than 0. And the range for ln x is going to be like that. So this relationship, that's one's domain is the other's range, is consistent, right? So if it's not for, these particular example, just any, the domain, for example, this domain, I'm going to call it, I'm going to give it a name for it, right? I'm going to call it, I'm going to give it a name called heart, right? And this range, I'm going to call it, what name should I give it to? Spade, right? And over here, the spade will be the domain for that, and the heart will be the range for the other. So the one's domain is the other's range. One's domain is the other's range. Always, this relationship is consistent no matter which pair of inverse functions we're talking about. And the function we are going to talk about now for, something called a restricted sign or constrained sign is going to be the same thing. So let's see how it's being created. Okay, so this relationship is consistent. What else relationship is consistent? What else relationship is consistent? And this other relationship, right? The composition, right? Remember we saw this before, right? I hope you guys haven't forgotten. Okay, f inverse of f of x is equals to x. Okay, provided x is in the, where's x? X in the domain of what? Of what? Of f, because f is the first one that works on x, right? And the other relationship is also going to be true under the it's also going to be true. So f of inverse of x is going to equals to x, where this letter x, even though it's the same symbol, It's actually in the domain of F inverse. This relationship is going to show up once again. In fact, any relationship, inverse relationship with domain range specified, they always, forever, for eternity, they're going to have this same relationship. Okay, so we're going to see in the details because the trig functions are a little bit more complicated function, right? Because we have to set the stage, we have to follow ARD. So this relationship is a little bit more complicated. But in terms of these critical properties, same, no difference. You just have to know how to use it. Okay, so with that introduction, so let's see how we can make some changes. Okay, how do we impose the constraint so that we can create an inverse function? Okay, so the idea of having for a function having inverse is that it has to be 1-to-1, right? So 1-to-1, in order to create that 1-to-1 function, we can see that there are pieces, right? So for example, this piece, that piece, and that piece, roughly when we see it, right? It looks like that this piece is decreasing function, and this decreasing function is going to be 1-to-1. So 1-to-1 has inverse. So if we pick a piece of a function sine from sine, then we can create an inverse to that piece. Or this piece, right? This piece is also decreasing. Or this piece that's increasing. So these bits and pieces, if we choose them correctly, it's going to be 1-to-1. And as a consequence of 1-to-1, and we will have inverse to those pieces, not to the entire thing. The entire thing doesn't have it, only the pieces. So among these available choices of the pieces, we want to pick the simplest one and yet most representative. The simplest and yet representative. And that piece of our choice, is this piece. Is this piece from here? Okay, from here all the way up here, the highest point and the lowest point. And how about the rest of it? The rest of it, we're going to truncate. We're just going to cut it off. We're just going to cut them off. And of course, this cutting is very easy to do it on the graph. It's just a chop, chop, chop. But there's an algebraic consequence. Right? So let's identify what's being chosen and what's being cut off. Okay, and that requires us to be able to read the graph, For example, what is the lowest point? Can you identify the lowest point and the highest point for me? You can use the unit circle to help with that identification. So what is the highest
point?
Go ahead. The highest point is what?
Oh, I was going to say the highest point is 1 and the lowest point is -1.
Well, your point has to have 2 coordinates, right? Input, output. So what will be the input? You have given the output. When is the output equals to 1? When is the output equals to -1? You're correct partially. Because this point, right, has a horizontal.
So Professor, x-axis is based on radian. That's why probably.
That's right. There's a horizontal and there's a vertical. Remember the way we made the graph? So what is that?
Wasn't it pi over 2 and then it was 1
That's right. Pi over 2, that's the input. Sine of pi over 2 equals to 1. Okay, so even if you only give 1, you only give the height, you didn't tell the input. Right now, your answer is complete. How about the lowest point? What is the lowest point? You can also use the unit circle to identify it, right? You look at the unit circle, you look at the blue numbers, right? You guys, this is not a test, you guys. You need to have all these tools laying out around you. So what will be the lowest point? Remember, sine is what kind of function? The input is A, well, yeah, I can use A. A is the input, A is angle, is radians. The orange arc length, remember we did that? The orange arc length, right? That's the input. And then the sine function, after sine functions comes out, what do we get? We get a ratio. That ratio, of course, is y over r, right? Then the y turn out to be the blue number if we choose the points on the unit circle. Remember the whole journey we did in the past? Is preparing for this moment. For this moment. Is everybody with me? So I intentionally choose the orange color. The orange color. The orange color, which is the arc length or the radian of the terminal of the degree measured from the center position. It's a whole ARD in our consideration. You guys follow me? The whole ARD is in our consideration. Does everybody follow me? So, and the output is that ratio. The ratio, what is the ratio? Think about definition. Is y over r. And what is y? Is the blue numbers. Do you guys see the blue numbers on the unit circle? Right? So that's what this curve is about. Okay, so that's the highest point. Can you tell me what is the lowest point? Everybody, please mark it. What is the lowest point? There's an input, there's an output. Input, output. Okay? Input, output. Input is orange, the orange color. Remember the arc length? The output is a ratio. You need to constantly remember these things, you guys. That's why I spend so much time to color tone them. Okay? So what is the lowest point? Tell me. What is the lowest point?
Would it be 3 pi over 2? 1? Negative 1, I mean?
-1 is correct, but what's the input? Negative pi over 2. -1. Right? Yes, 3 pi over 2 will also have an output of -1, but it will be on this other side. This point, this lowest point, remember this point is on the left-hand side, so the angle is measured clockwise. So this point would be 3 pi over 2, -1. Do you guys follow me? Yes? Yeah?
Yeah.
Any questions? Any questions? I think we should mark some more points. I think you guys are just didn't do that much. You didn't do anything beyond what I covered. Okay, so let's clean this up. Okay, let's mark points. In this relationship, okay, when we just look at sign and its ratio, right, with the unit circle next to it, right, with the unit circle next to it. We talked about that when we do pi over 6. When we do pi over 6, what do we get? We get to this terminal, right? And the arc length, which is orange, is going to be over there, right? So that orange okay? And the output is what? What is output? The blue numbers. And what you need to do, you need to imagine that if this angle is measured up to pi over 2, what do you get? And the entire arc length orange is going to be where? Where is it going to be? Right here. That's the input. And it's a positive, right? Because a positive angle. Now, the blue, what is the blue? Is this height. That's 1. So this orange is pi over 2. The height is 1. Now, if I measure clockwise to get here, the arc length would be negative because it's a negative pi over 2. And this negative is going to come over here. Right? That's the arc length. And the blue will be -1. So this -1 is the same as this -1. Do you guys follow me? Yeah? Do you see that relationship? What if I measure the angle up to pi? It's a positive angle measured counterclockwise from the standard position. And there's an arc length, which is pi. And what you do, your orange is going to be pi, this much. And the terminal is over here. The blue number is 0. So what is this point? Can you mark this point? Pi, 0, right? And what if I measure the terminal clockwise? What if I measure the terminal clockwise from this? Let me do green. Clockwise. Clockwise. That's a clockwise measurement of pi. What do we get? Where do you get the negative pi? It's on the negative side of the number line, isn't it? That's negative pi. And the arc length of this much. You can follow me? And what is that blue number corresponds to it?
Output.
What would that be?
It would be
Negative pi,
0.
0. You get it now? Yes?
Yeah.
Okay, so now give me the coordinates of these highest points and lowest point one more time. pi over 2 is right in the middle, right? Negative pi over 2 is right in the middle between negative pi to 0, right? Yes?
Yes.
So can you mark these 2 points for me, please? Mark it on your notes. Okay. So now I want you to do a little bit more. I want you to do a little bit more. Okay, with all that said and done, did you take enough notes? Okay, so I'm gonna give you an exercise. I'll give you exercise. Okay. You have your unit circle. You should have your unit circle. Whenever you come to class, you need to have your unit circle and all of these stuff next to you. Okay, I hope you have some space like that, where your stack of cards next to you. Okay. Now, what I want you guys to do is I'm going to expand this curve just a little bit. Okay, so I'm going to ask you to mark all the I'm gonna have you mark all these points. Okay. Mark these points. In the concept of A, output sine A. Okay. And you're gonna mark these points, the highest point, lowest point, lowest point. Okay. How are you gonna mark the points? You just saw the examples, right? You just saw the example. You're gonna mark all of these points. A, sine of A. Oh. Okay. You ready? Let's do the breakout room for just a couple minutes. Everybody must participate. Okay, these are the basics, bits and pieces, basics. If you don't get it, there's no way you can pass calculus. There's no way you can pass this class. No way, no way. But yet, to get to these bits and pieces takes patience and hard work, and you'll get it. You get it, and you will see the consistent theme of function. Okay, you're gonna see the consistent theme of function. Now, if you want to work with Farouz, go ahead with working with Farouz. Okay, just have this curve in front of you on a piece of paper. You don't have to sketch it perfectly. You don't have to sketch it perfectly. Okay, just have a curve, but you need to mark all of these points. Mark all of these points. And reflecting on the unit circle. Reflecting on the unit circle. when you're in calculus class in chapter 4, you're going to be talking about what will make the maximum output, what will make the minimum output. It's also about input output. But if you don't understand these basics, right, it's going to be very, very difficult for you. Okay, how are you guys doing? Have you marked these points? Input angle 0, output 0. Negative pi, 0. Negative 2 pi, 0. From this point, pi, 0. 2 pi, 0. From that point, pi over 2, comma 1. And this point, negative 2 pi over 2, comma 1. True. These two. All right, welcome back. Are you back? There's still 40 seconds. Oh, I made a mistake somewhere. So far, so good? Are you guys back? Thank you, Farouz.
You're welcome. Yes, we are back, Professor.
Very good. Very good job. Right? You can see how come 2 pi over 2, comma negative 1. Here we have a negative 2 pi over 2, negative 3 pi over 2 is pi equal positive 1. Right? It's all because of what? The angle measurement. The angle measurement. When you measure negative 3 pi over 2, you do it from standard position, measure clockwise. Your terminal is here. Isn't that ARD important or what? Isn't the ARD important or what?
Yes.
Absolutely. Absolutely. You just have to apply them over and over and over and over again. Sometimes we don't apply them because we have shortcut. We have this shortcut, that shortcut. Guess what? All those shortcuts will sidetrack you. You end up having to memorize a lot of things. When you actually solve a real problem, you're lost because you forgot the essential. That's why I don't teach you a shortcut. I don't teach shortcut. Okay? Eventually, you might figure out some shortcut yourself, but keep it to yourself. You still focus on this essential. Okay? Still focus on the essential. Okay? And what is the essential for trigonometry? ARD. Always, forever. One day, your grandchildren grow up and you have a trick question. What are you going to tell them? Focus on ARD. Okay? Focus on ARD. So this curve is a reflection of the ARD. So with that said and done, with all these points marked, now I hope you know what I'm talking about, right? So this piece itself has one-to-one. It's a one-to-one function that has inverse. This piece, it can also be used to make a one-to-one function and create its inverse. And that piece, we can also do that. So we have many, many pieces. How many pieces do we have? We can create those pieces and make one-to-one function and create an inverse function for them. We have infinite number of choices. But among the infinite number of choices, which one would be the simplest? Well, it's not up to us to decide, okay? Mathematicians hundreds of years ago, they have decided. They say, we believe that this piece is our simplest. And what are we going to do for the rest? Chop, 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 chop. But there's some implications about this chop. It's easy to chop it on the graph, right? What's the implication algebraically? That's the part we need to get to. That's the part you need to understand. If you don't understand, you still will be making all kinds of mistakes. This truncation tells us you angle the input, right? So we are creating a new function. This new function no longer has the domain from negative infinity to positive infinity anymore, no more. Okay, so we have to specify the new domain for this function. So this function is no longer the same as the one we used to know. And this input, okay, has to be between negative pi over 2 to pi over 2. And what does that mean for the unit circle? Right? You can only measure from 0 to pi over 2 or from 0 to negative pi over 2, right? That's between negative pi over 2 to pi over 2. And what's the implication of it is that when you measure your angle, you can only measure as far as over here, counterclockwise. You cannot go over. You cannot go over. If you go over, that will not be the function you define. Therefore, this quadrant is gone. You cannot use this quadrant. You cannot fly over. We can call it no man's land. No man's land. You guys understand what no man's land is, right? You cannot walk over. You cannot fly over. You cannot do anything over that part. On the other direction, in the other direction, right? If you are to measure clockwise, what can you do? You cannot go over this line. That's the farthest you can do. You cannot do this. No, that's beyond a negative pi over 2. So the farthest you can go is right here. And what does it tell you? No man's land. We used to talk about when we measure angles, right? We get here, we have this terminal, we can go around and round. Can we do that anymore? Absolutely not. You cannot fly over the no man's land, either with what do you call it? The new flying machine. What is it called? I just got stuck. It's the new flying machine, drone. You cannot fly over with drone, with airplane, with helicopter, nothing. You just cannot go over, cannot fly over. That's what I meant, cannot fly over. So
No
you are
fly zone.
fly zone, anything, okay? Your toy airplane, nothing can
Yeah,
fly over.
no fly zone.
No fly zone, no walk zone. You cannot walk over. Okay? You cannot run over. You just cannot get over there. If you do, guess what? You're gonna get a 0. You're gonna get 0. There will be a consequence. There will be a consequence. Of course, the consequence is much less severe than, you know, during war times. All right, that's the consequence. Okay, and there's a more consequence follows. There's a more consequence follows. Okay, because there's more algebraic work involved in it, right? So we can see the new function has a domain between negative pi over 2 to pi over 2, and this function as a whole, this function is a new function. Can you write it down as for yourself? This function is a new function. Not the same as the sine function we knew. Okay. But in the field of mathematics, when people mention sine to you, okay, at this point, a lot of our students will get confused. If I mention sine to you, right, then you probably say, do you mean the constricted domain or just a real number domain? Well, every time sine function is mentioned to you, it is meant to be the function we used to know, unless otherwise specified. Because if whoever talk about the sine function, they don't specify the domain, he or she always refer to the sine function that's defined over the entire number line. Do you guys understand? Because even though we spend so much time to talk about this function, once we get the inverse for it, we're going to forget about it. We'll almost forget about it. Do you follow me? Okay. So I'm going to mention this again after, okay? But anyway, so that was a sort of introduction. Okay. So after this truncation, all right, this is called a truncation. Truncation. Chop, chop, chop. Truncate it. And what is the consequence? Well, the consequential functions will be like this. This piece. This piece. Okay. So now on this piece, okay, with the unit circle next to it, I want you guys to mark some points. I want you guys to mark some points again. Okay, so now work with me. I'm asking you guys to be patient with me because I'm kind of going slow. If I'm too slow, please let me know. And the reason I make it slow, I want you to understand, I want you to come back to watch it and, just it's one of those things. When I was a student, I was just as confused as you are. Okay. And then it takes a long time to figure out. It took me a long time to figure out. You know me, it took me 4 times to pass the driving test. It took me, took me, 10 months to figure out. It might take you just 2 months. Okay. But I finally figured out. So I'm sharing that with you. Okay. So now, if you look at this picture, right? We have done the truncation. We've done the truncation. And all of these two, no man's land. So your angle can only measure this way or that. And no going about. Okay? Because we have, whatever we have. So next, I want you guys to mark some points. And I'm just going to ask you to mark a handful of points. I want you to mark this point, the highest and the lowest point. And maybe that point. That point. 5 points. Can you mark these 5 points? So after the truncation, what do we have left? Do we need a breakout room?
I'm ready, Professor. My table is ready with the table, those values.
Thank you. Mark those points. To tell you the truth, your professors, whether they teach trigonometry or they teach calculus, they don't have time to do this for you. These are expected of our students to do themselves, or they have learned this. They expect you to know. Okay. So let's mark these points. So even if you have taken trigonometry, you might have not done this before. Okay, if you've done it, great. If you haven't, I'm not surprised. But do we expect you to know? Yes, we do. Right? Those are one of those, many of those things that we expect you to know, yet we may not go over in class, but we expect you to know. They show up in homework one way or the other. Anyway, so this point, 0, 0, of course. And this point, pi over 2, comma 1. Those are easy. We've done them, right? Negative pi over 2, negative 1. It's these 2 points in between that are a little tough, right? I deliberately chosen some points maybe a little bit easier to identify. And this other one will be negative pi over 6, comma, negative half. Okay, so come back. If you haven't, so I'm closing the room. So these are the points. Okay, you certainly can mark more. I give you homework for you to mark more. Now, let's look at this curve. Look at this beautiful curve. It's 1 to 1, right? It's 1 to 1. And what's the domain and the range of this function? What's the domain and range of this function? Right, I'm waiting for those people to come back. Are you guys back? All right, you guys are back. Welcome back. Right? So what happens? Right, you mark these points, right? And this piece is the only piece we have chosen. And what is the function it represents? It's the sine function defined between negative pi over 2 to pi over 2. And what's the domain? What's the range? What's the domain? What's the range? Okay, I'm waiting for you guys to write this down, so I'm going to move forward. Okay, so we have a detailed understanding of this function. This function is just this much. It's just this much. Everything else is chopped down, and the correspondence on the unit circle, there's 2 second quadrant, third quadrant, you can never go there, and you can never fly over there, which means you cannot turn around and around, and you know, no fly zone or no man's land. Okay, that's the correspondence. For this function, we want to identify the domain and range because we know this function is 1-to-1, it has inverse. It is for this function, arcsine is defined inverse for. Domain is from negative pi over 2 to pi over 2. The range is between -1 to +1. -1, +1 is almost right. You need to use bracket. Thank you, Vincent. And the pi, negative pi over 2 to pi over 2, you also need to use bracket. That makes big difference. All right, so can you rewrite it, Vincent?
Yeah, I just forgot to put the brackets.
Thank you. Thank you for your contribution. Okay, so please rewrite it. Thank you. Negative pi over 2 to pi over 2 are included. Positive, -1, +1 are also included. That's why you must have bracket. Okay, you must have bracket. So now I'm going to clean this up. Let's look at this function. Let's look at this function. We finally found a function. That function. It's a new function. It's different from the function we used to know. Okay. And we know this function, we're going to call it G. G, right? G. G function. You can do G of X, doesn't matter. It really doesn't matter. If you change it to X, it just everything changes to X, right? If I leave it to A, there's just for one reason only. It's I want to emphasize the input are angles. The output are ratios, okay? Input are what? Angles. I have started mentioning this importance at the beginning. We are addressing trigonometry, didn't I? Okay, why? You will figure out why. So this sine function, this sine rule is still somewhat the same as in the definition, but it's just the domain is being modified. The domain modification to the existing sine function as we knew now is a different function. So the output is sine of A, which is a ratio. Ratio, input is angle, output is ratio. And we know this function has inverse. And we're going to call this inverse as g of -1 of x. Before I give it a different name, okay? I know that this new function is going to take what? Swap the input output. The input is going to be what? Ratio. And whatever this function is going to be, we know this is going to be G inverse, okay? Don't worry about its name. And this G inverse is going to produce what? It's going to produce angles. We know it exists. It's the one and only, and it has a special relationship. So if this is the domain is heart, the range, the domain is heart, and the range is a spade, right? And the inverse function's domain is going to be the spade. The range is going to be the heart. No matter what, always, forever. In math, that's the consistency I want you guys to see. Now I want you guys to look back for what we have done. Review for what we have done. Those functions at 1-to-1 we have done in the past. The exponential logarithm function we have done, don't they all comply with this pattern? And they must. It's meant to be. It's meant to be. So you see some simplicity here. Do you see some consistency here, don't you?
Yes.
Only the rules change. All right. Okay. So now what's the domain of this function? Of course, we already have it here. So what will be the range for the inverse function? Same. Before we name that function, we already know what's the range. Okay. What is the domain of, what's the range for the sign A? What's the range of G? What's the range of G? What's the range of G? Right? Vincent put it there on the screen, from -1 to +1. So what will be the domain for this inverse function? Same. Do you guys see that? Before I give it a name, don't worry about the name. We're going to get to the name later. This is the consistency I want you to see. And it will never change. If you're a math major, you're going to see this. If you're going to take 10 more math classes, you will see this will be consistent. If you take 20 more math classes, and you're math PhD in math, and this is going to be the same relationship. All right. All right. Now, and of course, for range, for the sign, we have another form. What is the other form? It's between -1 and +1. So these are the variations, the algebraic variations which are useful to us, right? And another form, of course, is going to be the absolute value of sine of A. Don't forget these, okay? These are very important algebraic forms. I will quiz you, test you, left and right, always until the end of the semester, until these things runs in your blood. Because I know you're going to get more points in calculus for doing this. All right? So these are just variations. They all mean the same thing. The algebraic form is more useful, right? I've said this many, many times. Now, let's look at the domain expression for this guy. What would that be? The absolute value of x, because we refer to the x here, it has to be less than or equals to 1. Right? Another form, what will be the other form? -1 less than or equals to x less than or equals to +1. It doesn't matter what I call this. I can call this this, right? And that would be, so it's just a placeholder, isn't it? It's just a placeholder. right? So these are the variations. How about this guy? Do we have variations for that? Do we have variation for that? Of course. Okay, I'm going to talk about that later. So this function, we finally get to the name of it. It has two names. Two names mean the same thing. Okay, the most traditional one is sine of whatever. And the other one, which has become increasingly popular these days, is that. It has two names. Two names mean the same thing. But this latter name is very confusing. The latter name is very confusing. How is this latter name very confusing? Because people tend to think that this sign, this is the inverse of the sign we used to know. No, this is the inverse to the sign to this guy. But this guy, after the inverse function is introduced, this guy is rarely used. Is rarely used. You can't even get a picture out of your calculator for this function. You can't. Unless you make adjustment to your frame, to your plot, you don't get it. Why? Because it's not necessary. You just have to understand the inner working of this process. Okay, so that's what we're here for. That's what we are here for. Okay, so now we're gonna do work today. We're gonna do work tomorrow to reinforce this, because once you understand the working of sine, it will be much easier to work on cosine and tangent. I'm committed to cover these three functions for you thoroughly, so that because these three functions, these three inverse functions are very, very much used in your future courses. Therefore, I'm going to give you some more coverage. And maybe arc cotangent, but I don't think that's necessary unless we have time. All right, so without further ado, so we have the big picture, don't we? We have the big picture already. So next, it comes to this inequality. Could I play with it? Right? Could I play with it? Well, this will basically say this guy, there will be other forms of it, right? So this guy, if you replace A, which is the angle, you can put it this way. You can see that? That's the same thing, because the angle is this guy, right? Right? So because the angle is this guy, and this guy is also the same as that. So I will have another form for it. You see, all these algebraic forms, you have to be able to recognize it. If I don't show you, you may not know. Well, I hope someone else will show you. Okay. So this guy is in between. Guess what? I'm going to quiz you about all of these in the future. I believe it's for your betterment. Okay. So now you understand where they come from, right? You know where they come from. Now we're going to do one thing, right? We mark these points. We mark these points. So we're going to mark some points. We're going to mark some points over here. I want you guys to complete the table. Complete the table. Okay. To mark the other points, pi over 4, pi over 3, those other points. I have make this assignment for your assignment. Okay, but because we have done it, I just want you guys to do one more, maybe two more, right, of your choices, right? We have 1, 2, 3, 4, right? And on the picture, I have marked these points, right? Negative pi over 4, negative root 2 over 2, and these points are already marked. And I want you guys to pick arbitrarily any two other points on this truncated sine curve and mark them. I'm going to give you 5 minutes. You have 3 choices. Okay, you choose two out of 4 and put them on your graph. Okay. You guys know what to do? Just mark those points. Make sure you understand. Breakout rooms. Any two out of 4. Any 2 out of 4. Oops, let me close the door. So this is a G. Are we good? I think I'm going to close. Okay, we don't need that much time. So that is G, right? You know the P, that piece of curve, domain range, right? All foretold from the outset, Let's get to the details. Okay, so you mark those points. Okay, I assume you guys know how to mark the points. Yeah, so let's move forward. How about the inverse, right? That's what we want to get to. The inverse function, right? The inverse function. Okay, the inverse function, right? So I'm going to put these 2 tables next to each other. Okay, this is the table. And this is the other table. This is the other table. I put these tables next to each other. One is for the G and the other one is for the G inverse. With domain range specified. Right? For pi over 6, the input, right? Remember these rules. Oops. Okay, the input is angle, the output is ratio. Right, the output is ratio. So the point is going to look like this, right? Angle ratio. How about the other one? The input is ratio X, and goes through that machine of sine or arcsine, whatever name now. Okay, it produces what? Produces angle. produces angle. So look at these pictures, right? So I'm going to make it just a little bit smaller. It's just a little bit too cumbersome, right? A little bit cumbersome. Now, you see, for the point of input pi over 6, the output is half. Input pi over 6, output is half. For the inverse function, the input and output reversed. And how do we write them? It's arcsine half, or sine inverse of half is pi over 6. So input is half, output is pi over 6. You guys follow me? For input pi over 2, sine pi over 2, the output is 1. So input angle, output ratio. And arcsine take the output and produces, takes the ratio as input and produces output as angle. I want you guys to write each of these blanks, to fill each one of these blanks. And then we're going to plot the points. I want you guys to write them as the way I write them. Okay, I want you guys to write them the way I write them. Do you guys know what to do? Yes? Input angle, output ratio. Input ratio, output angle. But the angles must be between negative pi over 2 to pi over 2. Okay, all of these angles must be between negative pi over 2, which was, we talk about the range. And the input has to be between -1 to +1. You guys ready to go? Yeah? All right, open all rooms. Okay, I want you guys to fill all the blank and plot points. I have another picture for you guys to plot. This one, the blank space to plot. Okay, but I think I cannot hold them in one screen. So let's do one thing at a time. Okay, so this is for the G and that's for the G inverse. So you guys are gonna fill out the points. You guys ready? Okay, so I should give you guys 5 minutes, maybe more. Okay, give me a second. I'll be right back. Farouz, if you, oh, I think he's in the room. He's in the room 1. Okay, so I'll be back. Okay, just 1 second. All right, how's it going?
It's going well.
Excuse me, I think you're muted.
Thank you. So we not only need to understand the graph and the ideas and all of these properties, you have to be able to perform. You have to be able to write the algebraic form correctly. Yeah, you know what I mean? So there's a different aspect of it. On the one hand, you understand, you see, oh, I understand. That's not enough. That's not enough, I'm sorry. Okay, you have to be able to write it down so other people understand you understand. Do you guys follow me? So this exercise is to show you, okay, how do you show other people you do understand? Especially to those nerdy professors, right? So input, output. I wrote two forms because in the future, you don't know which form your professor prefer. Okay. And sometimes they use it interchangeably, and you don't want to get stuck there because they use different forms interchangeably. Right? So the best way is to get familiar with all the forms. I totally understand when your professor write down something on the board, you don't understand, you're going to stuck there. The professor going to keep talking, then you just stuck there, and then you don't understand the rest of it, right? Does that happen to you? It certainly happened to me. Because when you look at that, I said, what is that stuff? Never seen it before. One thing you can do is raise your hand and ask the question. Sometimes you're just not fast enough. Okay, so the next one. So I'm asking you to write it the way I do to get familiar to both forms. And I'm going to also point out some mistakes. Okay, I'm going to point out some mistakes. And these mistakes are very common. I saw them in my calculus classes. I saw them in my pre-calculus classes. Those mistakes reflects fundamentally the lack of understanding, and the lack of practice. Like Farouk said, practice makes perfect, right? Practice makes perfect. So I'm going to close all the rooms. I'm going to close all the rooms. Okay, I'm going to close all the rooms. So finally, Arcsine. All right, is everybody back? So look at these two functions, right? When we recall, right? Recall how do we get inverse, right? One of the step is the first step is to swap x and y, right? And what the consequence of swapping x and y? There's so many of them. There's so many cases of that as a consequence of swap, right? Swap xy causes domain range to swap. It caused the coordinates to swap. Let's look at the picture. Let's look at the picture. Okay, so this is the picture. For the arcsine. And this other picture, I have it for sine.
Professor, can we call it restricted sign or one-to-one sign, one-to-one version of sign? Because you said it's a new function. We can give a new name. We can.
What name do you want to call it?
It's a restricted version of sign.
Sure,
One
sure, you can do that. Yeah, restricted version.
or
Oh.
one-to-one version of sign function.
Sure, you can do that.
Thank you.
All right. So now what I'm doing here is that this is for sine, the restricted sign, or one-to-one version of sine, and the other one is its inverse. Okay, I plotted some points there, and I want you guys to plot the rest of the points on the dots. I already give you the dots. I've already given you the dots. Okay, I cannot hold all of them in the same picture, right? You have the table in front of you, don't you? Do you have the table in front of you? So now I want you guys to put them on the dots. You'll be quizzed on, okay? You'll be quizzed on. And then we're gonna bring the two pictures together. We're gonna bring the two pictures together. That's after the fact. After we're done with the plot, the graph, the points. Okay. The green is the restricted sign, or the one-to-one version of the sign. Okay, those are pretty good names. And the other one is its inverse, G inverse. Okay. Do we need to open breakout rooms?
We didn't finish the inverse function, the table of it, Professor. If you want to open breakout room, couple of minutes.
Oh,
between
okay.
practice
Well,
makes
I can open up the rooms. Thank you, Bruce.
You're welcome.
Okay, if you guys want to go back over, just be patient with yourself. Write down the notation. So this will guarantee you write down the notations 10, 20 times. You better get it. You have to get it. You will get it. Right? Write it down correctly. The graph, the algebra, the implication.
Professor, can you show the graphs? Can you scroll down?
Sure. You can see that pi over 6 half that the green dot on the restricted sign, and on the arc sign is half comma pi over 6. You can see that correspondence, right? Pi over 2 comma 1 now become 1 comma pi over 2. Negative pi over 2, negative 1 corresponds to that point. So these are one-to-one correspondence. That's one-to-one. That's one-to-one. So when you swap x, y, there's no ambiguity. From input, you can find output. From output, you can find input, unique, corresponding to each other. You see that? How's it going?
Good.
Let's look at chat. I saw Vincent writing curly brackets. No, you don't use curly brackets. Okay, you use brackets. Vincent, are you here? Thank you for your response. Okay, when we express domain and range, in these cases, we don't use the curly brackets. We don't for sign. I'm seeing the situation for sign.
Yeah,
Okay.
I just messed up because I didn't know I didn't have to push shift, and the text was too small on my screen to see it.
No problem. No problem. I understand. I just want to make sure I saw your correction. So I assume that's a correction, but I just want to clarify to make sure, right? So whenever the points are included, the last piece that Winston put there is the perfect answer. Okay, thank you for doing that. Good job. Good job.
Professor, what would we label these graphs? Would we label the red one Arcsine? I mean Arcsine.
The red is Arcsine, the green is the restricted sign. So
Okay.
you're gonna label the points on the green for the sign. The red one for the Arcsine. You see there are examples on it. Do you guys see the points well? Okay, I'm closing the room. I want to have a closure before we end, we end today's class. And of course, tomorrow we're going to continue and we're going to make sure this is thorough. And I already give you guys homework on these topics to reinforce, and there will be a quiz about it. There'll be a quiz about it.
Thank you, Professor. We are back.
Wonderful. Oh. All right. Any questions? So as you said, this green curve is a sign, the restricted sign or the one-to-one version of sign. Okay. I want you guys to mark these points. I trust you guys have done that. And this is the Arcsine. This is the Arcsine. Which is in red.
Professor, isn't the one for negative pi over 4 and the root, is that 2 over 2? Isn't it supposed to be 3 over 2?
Which one? This one?
For sine x right here on the left. It's
On
the
the left?
second, yeah. You see how you have it negative root 2 over 2?
Negative root 2 over 2, negative pi over 4. Do you mean this one?
Wasn't it supposed to be negative root 3 over 2?
No. For negative pi over 4, it's negative root 2 over 2.
Okay,
For pi over 3 is negative root over 3, negative root 3 over 2, comma, negative pi over 3. So this point, okay? So let's just have a closure. Okay, so this point, okay? I should use red. So negative root 3 over 2 Okay, negative pi over 3. And this point over here is negative half, negative pi over 6. Okay, on
Okay, I
the
got
other
it.
side, you guys got it?
Yeah.
We only use the special angles, but you can see why the special angles serve the purpose, right? Remember, I once said to you many times I said to you, the special angles are in service, they're in servitude. Service what? Service ARD. Okay, so the green, to get the green point, you do ARD. To get the red point, you do what? You get DRA. DRA, because from the ratio you look for angle, right? From ratio from the definition you find the angle. But the ratio has to be specific, the angle has to be specific. So we're going to address more of that in tomorrow's lecture. But today, I just want you guys to get the points correctly. And I have given you homework for it. Okay, so please take the homework very, very seriously. They're easy to do and they're easy not to do. And I will be quizzing you guys on that. Okay, you probably have seen it. Okay, you've seen the homework assignment already, right? So you mark these points. What if we bring them together? What happens if we bring these two pictures together? So that's the topic discussion we're going to do tomorrow. But you can get started now. Okay, so this is sine, this is Arcsine. I'll see you guys tomorrow.
Thank you, Professor. See you tomorrow.
Thank you, Farouz. It's a great
You're
work
welcome.
in the breakout rooms.
You're welcome.
See you guys tomorrow.
Thanks for the lecture, Professor.
Of course, anytime. Great job. Okay, great participation, right? You're laying the foundation for your future success.